Hi, in this video, let's discuss how to solve this equation and also the correct write-up style. Y over 2 plus y over 3 equals 5 over 4. So solve an equation means find all numbers y for which this equation is true. So we start off with assume there's a number y that satisfies the equation. So y is a number, this is a number, and this is a number. And now we can do all the operations that we usually do with numbers. I'll rewrite the equation here, and today I'll show you two ways of solving this equation. Both ways are about clearing the fractions. They differ in the number I choose to multiply both sides by. So let's look at this write-up right here. First thing to notice is I do not convert fractions into finite decimals. In fact, 1 over 3 you cannot convert into finite decimal. But we do know this is a number and this is a number, and we can multiply both sides by the same number. Here, the magic number I have chosen to multiply both sides is 24. Where do I get 24? 2 times 3 times 4. It's just the product of the denominators. In any problem, if you do that, that number will always work in clearing the fractions. There are also other smaller numbers that may work, and that's what we'll discuss in the method too. For now, let's stay with 24. Look at the write-up style. I take this whole expression and close it in parentheses and then put a 24 there. Here too I do the same. Do not simply write 24 in this problem. Do not write 24 and put a big parentheses and multiply the whole equation. You must multiply 24 by the left hand side like this, put an equality sign, and again rewrite the 24, and then whatever you have, that number there. You may want to use color pens to keep it all clean and very clear. Now at this point, we simply apply the distributive law of numbers, because y is a number, this is a number, and this is a number, and that's a good place to apply the distributive law. When we do so, we get 24 times y over 2, 24 times y over 3, plus equals, and here instead of multiplying 24 times 5 and then dividing by 4, I handle the numbers in this manner. I think ahead, and I know 4 is going to go into 24, so I write 24 as 4 times 6, and then 5, 4. And some of you may be ready to just do this in your head. 4 goes into 24 6 times, and that 6 times 5 is 30. You can also do that. I've just written out more steps just so that you understand everything that's going on. And here 2 goes into 24 12 times. If you prefer, you can rewrite 24 as 2 times 12, and then using the cancellation law of fractions, you can cancel the 2's. You're welcome to do that. But if you can do it in your head, then you're good to go. You can write 12y, and here 24 times y over 3 is 8y equals 30. So as you can see, we had an equation with fractions. We were able to multiply both sides of the equation by this magic number to clear the fraction, and we are here where we have an equation without fractions, and that's a good thing, because this equation is pretty easy to solve. So now, 12y plus 8y, again by the distributive law, we can combine those like terms, and it's 20y equals 30. Divide both sides by 20, and here you probably don't need this step. You can really jump to y equals 3 over 2, but I wrote it out anyway. 30 is 3 times 10, 20 is 2 times 10. By cancellation law of fractions, we can cancel the 10's, and then we get y equals 3 over 2. And we would like to say y equals 3 over 2 is the solution, but wait a minute, we must do check work. And here, notice how I handle the check work. I write the left hand side expression. I put in for y 3 over 2. What we have here is a complex fraction, a fraction over a fraction. So by another rule, this complex fraction is simply 3 over 2 multiplied by the reciprocal of 2, which is 1 over 2. Same thing out here, 3 over 2 times 1 over 3. Do not do log division and all of that. This is really a complex fraction, a fraction over a fraction. You must convert it. You must use the invert and multiply rule, which I explained in another video, the logic behind it. And this is what you get. And now it's 3/4 plus 1/2. At this time, we do not have a common denominator. So by using the fundamental fact about equivalent fractions, you can create the common. You can multiply 1 over 2, top and bottom, by 2 to get 2 over 4. Now you have fractions with the same denominator. You can add them, and you get 5 over 4. 5 over 4. So it looks like y equals 3 over 2 does satisfy the equation, and we get to say it is a solution. So practice this write-up style, and I'll also now show you method 2, where in fact we multiply both sides by 12. So let's look at that on the other board. So here's the equation again, and we notice to clear fractions, all we need to do is choose a number to multiply both sides by, so that once we apply the distributive law, somehow the fractions disappear. For that to happen, each number in the denominator must go into whatever magic number you choose. There we chose 24, which is the product of 2, 3, 4. That will always work if you just simply take the product of the denominators. That will always be a good magic number. In this case, it also happens that 12 is a number that all three numbers evenly divide into. So we could choose to multiply both sides by 12. But if you cannot remember a small number, this is actually called the least common multiple of 2, 3, 4. If you don't know how to find that, then you're good to go if you simply take the product of all the denominators as in method 1. Again, pay attention to the correct write-up style. I must have an equality sign. Every line is an equation, and here I take the entire thing, put it into parentheses, and you see a 12 here, you see a 12 here, and all of that good stuff. Now here, it's a matter of using the distributive law of numbers. Remember, y is a number, so this form should remind you of the distributive law. So if you apply that, we get 12 times y over 2, 12 times y over 3 equals, here again, why bother multiplying 12 times 5? If you just think 4 is going to cancel, 4 goes into 12, you can rewrite 12 as 4 times 3 times 5, and now by the cancellation law of fractions, 4 gets cancelled and you get 15 here. Here too, again using the cancellation law of fraction, this simplifies to 6y, this simplifies to 4y equals 15. So now again you can combine like terms, and the logic behind combining terms is again the distributive law of numbers. If you do that, you get 10y equals 15. Divide both sides by 10, y equals 15 over 10. 5 is a common factor of 15 and 10. You may rewrite 15 as 5 times 3, 10 as 5 times 2. The common factor of 5 cancels, and 3 over 2. Same answer as we got in the first method, y equals 3 over 2. So it's up to you which method you want to choose. Whatever you do, maintain the correct write-up style, and also be sure to show check work. Thank you.